going to be a quick one. We'll be showing how to make use of Git in antigravity IDE. I have created a folder named data science in my debugging myself, and to make use of this, to set it up and make it feel like a data science project, we have to install some dependencies and files we will need, some libraries we'll be making use of during the course of the tutorial. Pip is quite slow in doing that, so I'll be making use of UV, and to quickly set this off, I'll be using UV init. Then I'll be putting just a full stop here, a full stop in place since I've already created the folder. So I'll just be initializing the dependencies inside this already created folder. If I am planning to create a folder here, I'll be naming the folder at a particular point, but I want everything initialized here in the data science folder. So I'll be hitting enter here, and voila, that's it. We have a Python version which is set to 3.12. In.py is scripts that can be run automatically to check if our setup is working. Then we have python.toml that contains our dependencies and some other set of instructions, and then a readme.md that gives a blank readme.md that can be populated to describe what our project is all about. So to continue, we're making use of some libraries that I'll be making use of. I'm making use of pandas here for what we want to do. So with UV, we'll be making use of UV add pandas, and once we do that, in seconds, you see why I'm making use of UV. No need to be setting up with pymans.whatever.txt. All you just have to do is make use of this, and then we have our project.toml with our dependencies here for us, easily managed and quickly managed. So we have our pandas installed. We'll be making use of IPyKernel because we'll be running most of our tests in our Jupyter interactive window. So I'll be using UV add IPyKernel. I'll be using a dev here, --dev here, meaning I'll be using this at this is just a way to set up your dependencies. As you can see, dependency group is set to dev, so to differentiate between what you'll be setting up locally and what you'll be setting up for deployment. So I think with this we are good to go. So first I'm going to be creating a new file, and I'll be naming it test.py. And before we continue, let's install git lens before I forget. So for this to work the way as how we planned, we're going to be installing a new extension called git lens, a VS Code extension called git lens from the marketplace. So this is already installed, so you'll be seeing an install button. If you've not installed before, but since I've installed it, you'll be seeing a disable and uninstall button in case you want to do that. So since we have this installed, we're just going to go on and continue with what we are doing before. So coming back to our test.py, I'll be importing import pandas as pd. Then we create a data frame. No, the data. Okay. So we have our database, which is going to be a column of name, age, and city with some rows assigned to them. So we'll be importing this as a data frame. We'll be doing pd.dataframe, pd.dataframe. Put our data here. So as we continue, this gets fun. If we're making use of our Jupyter notebook, we'll be running this cell by cell. So let's just try to replicate that by using our shift and enter. As you can see, automatically starts up a kernel similar to what our Jupyter notebook will be doing. And as you can see, it's trying to import the pandas and taking good. It was able to install pandas. So we can also do that. Just assume that this is also a Jupyter cell, and then we do the shift enter also. Voila, our data is imported. So converting this to a data frame will be same also, which is successful. And finally, let's visualize our data. We have print df.head. The data is not that large, so just print it like that. Sorry for this. And we run this also, we get, and well, here we are. Here's our data, matter 25, New York City, Los Angeles, and this is our data frame here in matter of seconds. And as you can see, there's also an option to copy this and run this down here. So you get the similar response. Actually, this feels like a Jupyter notebook. So this is one of the advantages of using IDE instead of our Jupyter notebook. We can still write this code cohesively at once, and at the same time run it bit by bit like our Jupyter notebook. So next, I'll be showing you how to make use of Git. There are some essential Git commands that you can use via our CLI, but we'll not be going through that at this particular point. We are more interested in using the integrated development environment for this. So we come to the source control, click on this, and as you can see, all the files changes we'll be making has been tracked already. You see the Python version file that we created, the main.pl file, the pyproject.l, readme.nb, then test file, then there's a UV log file also created here. So all we're going to be doing now is just commit this, and then we'll create a message. Our message is, it's the first time I'm doing that, so we're going to do first commit, and we click on commit. And once that is done, everything here is clears up, and then we come back here. And then you see, notice this was green in color before, but the moment we committed, it shows that okay, yes, we've committed this to stop tracking it, and everything here is up to date. So that is to help us have a checkpoint that we can always come back. So at this point in time, we know we have our database comfortably imported. So anytime we come back to this first commit, we know that okay, at this particular point in time, we have our project set up, and we have our database easily imported. So we noticed something, that running git init, we always do the same thing for our project, meaning over and over. Anytime we run git init and all of that, it should set up our Python version, our python.home, our readme.md, and our uv.log. So we don't want this to be in our git history. We want to, in case someone else wants to, we want to push this to our GitHub repo. The issue with keeping this merge file in our local in our commit is that sometimes there'll be secret files that we want to send, and the more you build, the larger these files get, and then you want to exclude them from our git, from our from being tracked by git. So to do that, we create a git ignore file. Git ignore file, and then we include the names of the files we want to ignore. .python .vinf file ignored, .python version. Okay, we might need that. So the only file for now that we need not commit for now is our .venv file, because if we remove the .venv file and let's do that and see, we remove the .den file, delete it, and then we do a UV sync. Sorry. We see that our .venv file is automatically created and brought back. So this is a file that we don't need to be pushing to in our Git repository, in our local repository. So it's better we leave this untracked. And the only way to do that is to create a Git ignore file and put the name of the folder, the file, or whatever you want to track or not track anymore here. So once that's done, we'll be moving on to the next change, just to show us what happens when we do git ignore. But before then, let's try and push this. So see, we created a new file. So when we commit this file, we say add a message, added .git ignore, and then we commit this. So once we've done that, you see there are no changes for us to follow. And down here we can see the we can track the changes made in our file. We have this, we added git ignore for the first commit. You notice the amount of files we have here. These are the files we committed to it, and in the second one, the only file we committed was the git ignore. So next we'll be publishing this to branch, and then since we have, I already once you click this, if you are doing this for the first time, it will ask you to connect your GitHub. You have to sign your GitHub account to the to connect it with your antigravity and the IDE. But since I've done that already, it's going to ask me for a repository name, which data science currently is available. So I have to publish it in a private repository or public repository. For this particular exercise, we're publishing our changes in the public repository. So I'll do this, and by clicking that, it's automatically published. And from what you're seeing here, it is sending it to GitHub, and we get a successful message here. We'd like to open. Would you like antigravity? As you can see, this is our master branch. So on the master branch, this was all committed just now. It's on our master branch, and then we have the git ignore file, the Python version readme.md that was blank, the main project that we initiated. Everything we just pushed from our local repository was sent to GitHub, and these are two commits. The commit messages that we did. First commit was was the first commit. The second was we added a git ignore. This is our commit hash. So with this done, we'll be moving back to our antigravity IDE. So back here, we'll be creating a new file. We'll be calling it env.py. So there are cases where we will need to create API keys, and then let's say this is fish and your username. Let's call that @gmail.com, and a password. We call that my password. So this is, under normal circumstances, this will be an API key, a secret key. The username might be public, but then the password, we need this to be able to run our app, but this is not something we should be committing to the public. So this brings the need to add a .env file to our project, and to do that, we'll be adding a new file. We call that .env. Now the .env file will be added to our GitHub, meaning this file will not be committed or not be tracked by Git in any way. So if we come back to our .env here, we notice it's not tracked by Git at all. This is being tracked, this and this are not being tracked by Git. So we can come and move two of them into our these variables into our .env files, and this keeps them safe. Now, how do we bring them back and load them in our .env file and .env.py, like a file we need to make use of? So to do that, we'll be making use of uv add. We'll be adding our .env library. So to make use of our file saved in our .env file, we'll be importing OS, operating system. Sorry about that. OS, and we'll be importing from .env. We'll be importing find.env and load.env. So first and foremostly, we'll look for the location where our files have been saved. So we can see file directory. File directory is equal to find.env. So we're looking for our where our .env file is saved. To track this and view it like that of a terminal, let's clear this, and then we try to run this as an interactive terminal. Shift and enter. Okay, it creates a new tab for us. So importing OS, connecting to the .env file. Let's wait a bit. Alright, our imports are successful. So let's see the results of this file. Let's try to find the directive. So it was able to find the directive of that. Let's print what's found here. File directive. So we put that, and voila, this is telling us that the file is located in the roots of the data science project. So in cases where your file is not located at the root directory, it will be able to scan backwards to check till it finds the .env file before it continues. So then we now say, okay, load .env. We're going to be loading our .env, then we put our file directory as the location of our .env file. So this can be avoided also. You can just directly load .env and then you put your .env file there. But this is a much more ideal way to do it, so that you can be able to get the exact location of where the .env file is. So now for us to call any of the variables, let's say for example we want to view our API key. So we can now come to our env.py and we can say that name a variable API key is now equal to os.getEnv. Then we check the name. The name we used to save it there is API key, so I'll just use autocomplete here, and then I'll print my API key. So from here, let's run this. Let's run it individually. First and foremostly, let's do this shift enter. And voila, you get that. And then escape for now. Then we go and print this, and this is our supposedly hidden API key that's in our variable here. So we've been able to call this in our env.py in a way that nobody can see. So we can push this for anybody that wants to make use of it without exposing our secret keys. Let's do the same thing for our username and password. Then we're printing that. Print API key, print username, print password. So let's just run this together as a cohesive file and see what will be outputted. There we go. So this is our API key, this is our username, and this is our password. So by doing this, we have been able to, in a secure way, keep our keys safe here, and at the same time we've been able to import them into our file. So let's now go and commit this. This is one of the advantages of a Git ignore file. The .env file now will be safely left here in a local file drive on our device without being pushed to the cloud that's on GitHub, and then Git will not be tracking any of this or this. So coming here, we commit, we say created, let's say created so after doing that, we commit this, and then voila, we get a new commit. So this new commit has git ignore.env file project.tom and uv were updated due to our uvr.env, so these two were updated also. So first commit, I did git ignore and created this. So the sync changes means you push this commit to, and then you do that, we stage this and push it to our main branch of GitHub, and then we'll go and view that. So as you can see, our new envelope.py is here with all of what we've written just now without committing our important environment variables to our GitHub. So, and we noticed we did everything on the master branch here. In some cases where you don't want to always touch the master branch, you can always make use of the production branch. And so to do that, you set for master branch, you create a new branch. You can create a new branch to maybe call it development branch, call it development, and voila. So any changes you'll be making now will be staged to the development branch, or you can check out to your master branch back. So you should have a basic idea of how to make use of antigravity IDE for running Git and version control in your data science project. For now, thank you.